What if we moved Earth? Not a spaceship, not a moon base. The entire blue planet, shifted through space like a cosmic billiard ball. Sounds like science fiction? Maybe. But under the right circumstances, and with a bit of imagination, it's a question worth asking. What happens to the climate, time, gravity, and life on Earth if we move our planet? Today, we're exploring one of the most mind-bending what-ifs in cosmic engineering. Imagine this: Earth, our entire planet, slowly shifting its orbit, gliding through space like a massive cosmic ship. No, this isn't a deleted scene from a sci-fi movie. This is a real scientific idea, explored by some of the most brilliant minds on the planet. Why would anyone even consider such a thing? And more importantly, could we actually do it? Let's start with the why. Earth's position in the solar system is perfect, for now. We're in the Goldilocks zone, not too hot, not too cold. But that comfort won't last forever. In roughly 5 billion years, our sun will run out of fuel and swell into a red giant, likely engulfing Mercury-Venus, and possibly Earth. And that's just one potential doomsday scenario. What if a rogue asteroid suddenly threatens to collide with us? What if we discover another, more stable region in the galaxy, far from cosmic radiation and black holes? What if humanity wants to extend its survival not just for thousands of years, but for millions? That's when the idea of moving Earth starts to make sense, not as a fantasy, but as an act of planetary preservation. So, how exactly do you move a planet that weighs over 6 sextillion tons? Surprisingly, science has proposed a few daring methods. One idea involves gravity assists using asteroids. It works like this. You take a massive asteroid and redirect it to swing close past Earth, again and again. With each pass, the asteroid transfers a tiny bit of its momentum to Earth, nudging our orbit slightly. Do this enough times, and Earth's trajectory can be altered. It's the same principle NASA uses when slingshotting spacecraft around planets, but scaled up to a mind-boggling degree. Then there's the idea of solar sail tugboats, giant reflective sails, hundreds or thousands of miles wide, floating in space. These would catch sunlight like a breeze and pull Earth ever so slowly. It's gentle, elegant, and technically clean, but the scale would be unprecedented. We're talking about constructing structures the size of continents and maintaining them for centuries. Still not extreme enough? Enter nuclear or fusion propulsion. The concept: install titanic rocket engines either on Earth's surface or in orbit, firing in the opposite direction of where we want to go. These engines would need to burn continuously for thousands, maybe millions, of years, gradually shifting our orbit. Nuclear fusion, the process that powers the stars, is one possible fuel source. The technology doesn't exist yet, but it's one of the most theoretically powerful and efficient ways to generate thrust. All of these ideas are fascinating, but here's the kicker. The energy required to move Earth even a little bit is beyond comprehension. To shift Earth's orbit significantly, we'd need somewhere around 1029 joules of energy. That's more than the total energy output of the entire human race across all of history, by a factor of billions. It's not just big, it's astronomical. To achieve that, we'd need technologies we don't have, like Dyson swarms that capture nearly all the sun's energy, or antimatter reactors far beyond our current understanding. Even if we had the energy, we'd need to use it with incredible precision. A tiny miscalculation could send Earth spiraling into the sun, or flinging out into the dark void of space. One wrong move, and we lose everything. So, is it possible to move Earth? On paper, yes. Physics doesn't forbid it. But in practice, the engineering hurdles are overwhelming. We're talking about operations that would span tens of thousands of years, require global unity on a level we've never achieved, and involve risks so huge they make climate change look like a warm-up act. Still, it's a fascinating thought, and perhaps most importantly, it forces us to ask deep questions. If we had the power to move our planet, would we use it wisely? Would we move Earth to save it, or to escape our problems? And are we even capable, as a species, of handling that kind of responsibility? In the next part, we'll explore what actually happens if we did move Earth closer to the Sun, farther away, or even into a whole new orbit. Spoiler, it's not just the scenery that changes. It's time, climate, seasons, and life as we know it. So let's say the impossible has happened. Humanity has pulled off the greatest engineering feat in history. We've nudged our entire planet, yes, all 6.6 sextillion tons of it, into a new orbit. But now comes the real test. What does that actually mean for life on Earth? The short answer? Everything changes. Earth's orbit isn't just some random loop around the sun. It defines our seasons, climate, ecosystems, and even how we measure time itself. Move the planet even slightly, and we disrupt a delicate cosmic balance that life has spent billions of years adapting to. So what happens if we get closer to the sun, or farther away? Let's start with the first scenario. Scenario 1. Moving closer to the sun. At first, it might sound kind of nice. More sunshine, warmer winters, longer growing seasons. What's not to like? But that small shift inward comes with a steep price. As we inch closer to the sun, Earth begins to soak up more solar radiation. Temperatures rise, and they rise fast. Even a 5% decrease in our orbital distance could increase solar energy by over 10%, triggering dramatic climate shifts. The polar ice caps would start melting at an accelerated rate. Within decades, maybe less, we'd see massive sea level rise, flooding coastal cities around the world. Major population centers like New York, Tokyo, Mumbai, and London would be swallowed by the ocean. The tropics would expand north and south, pushing hot, humid conditions into regions that were once temperate. Deserts would grow. Forests would dry up. Agricultural zones would shift, collapse, or vanish. Crops that feed billions, wheat, corn, rice, might no longer grow where we need them. And then comes the truly terrifying possibility, the runaway greenhouse effect. This is what scientists believe happened to Venus. Billions of years ago, Venus may have had oceans and a habitable climate. But as it got too close to the sun, water vapor, an extremely powerful greenhouse gas, started to accumulate in the atmosphere. That trapped more heat, causing more evaporation, which trapped even more heat. The cycle spiraled out of control. Today, Venus is a scorched wasteland with surface temperatures hot enough to melt lead. Could Earth suffer the same fate? If we moved too close, yes. The oceans could evaporate, releasing vast amounts of water vapor into the atmosphere. Over time, Earth could transform from a vibrant blue world into a lifeless, toxic furnace. Scenario 2. Moving farther from the sun. Okay, so moving inward is clearly a bad idea. What about the opposite? What if we drifted outward, say, toward the orbit of Mars? At first, it might feel like global air conditioning. Cooler temperatures, fewer heat waves. But again, that's only the beginning. The drop in solar radiation would cause average global temperatures to plummet. Polar regions would expand, encroaching on what are now fertile farmlands. Massive ice sheets would grow across North America, Europe, and Asia. Snowfall would increase, reflecting even more sunlight away from Earth in a feedback loop called ice albedo, which would accelerate the cooling even further. Welcome to Earth's next ice age. Crops would fail across much of the world. Tropical and subtropical plants wouldn't survive the frost. Food production would collapse. Billions could face famine or be forced to migrate toward the equator. What little habitable land remains. Entire ecosystems would go extinct. But it's not just the temperature we have to worry about. The amount of solar radiation reaching Earth is also tied to our atmospheric behavior and magnetic field. Less sunlight means less energy for the planet's weather systems. Storm patterns would shift dramatically. The jet streams that regulate climate might break down entirely. And Earth's magnetosphere, which shields us from cosmic and solar radiation, could be weakened if the balance of incoming energy changes. We might face higher exposure to ultraviolet rays, cosmic radiation, or solar flares. especially if Earth's protective magnetic bubble becomes unstable. Time itself would change. As if freezing or boiling the planet wasn't bad enough, here's something most people overlook. Changing Earth's orbit also changes our calendar. Right now, Earth takes about 365.225 days to orbit the Sun. That's the foundation for our entire system of time: years, seasons, agriculture, school schedules, religious holidays, everything. If we move Earth closer, the orbital period shortens. We'd have shorter years, maybe 300 days, maybe fewer. Seasons would fly by faster. Our concept of time, aging, and planning would all be thrown into chaos. Farther away? The opposite. Years could stretch to 400 or 500 days. Winters would last longer, and growing seasons could disappear entirely. Animals that rely on daylight cycles to migrate or reproduce would be disoriented. Plants might not bloom. Entire biological clocks, ours included, would fall out of sync. And let's not forget human society. We've evolved to live in a very specific cosmic rhythm. Shifting that rhythm even a little could send civilization into cultural and psychological shock. How do you plan a harvest when spring doesn't show up on time? How do kids go to school when a year no longer fits into 12 months? Imagine waking up one morning and stepping outside to find no sunrise, no golden glow peeking over the horizon, no warm daylight gently spilling across the trees, just blackness. Endless, all-consuming darkness stretching across the sky. The stars have vanished, the moon is gone, and the air? Bitter cold. You're no longer on a planet orbiting the sun. You're on a rogue world, drifting silently through the dark ocean of interstellar space. That's what happens if we move Earth entirely out of the solar system. It may sound like science fiction, but rogue planets, worlds with no sun, are real. We've detected dozens of them, wandering alone between the stars. Some may have been ejected by their parent systems. Others might have formed alone in the void. But if we ever decided, or were forced, to move Earth beyond the reach of the sun, we'd be signing up for a journey into the ultimate unknown. The first consequence would be swift and brutal: the loss of sunlight. Without the sun's heat and radiation, our planet would begin to cool rapidly. Within just a few weeks, global surface temperatures would plunge below freezing. Within a year, average temperatures would fall to around 100 J, 73 degrees, and from there, the descent continues. Eventually, Earth's surface could reach 400 D, 240 dt, approaching the background temperature of a deep space. The oceans would freeze solid, starting from the top. Ice would creep down mile by mile, sealing Earth in a glacial tomb. Only one thing might stop total extinction: heat from within. Deep beneath the surface, Earth's molten core continues to churn. Geothermal vents at the bottom of the oceans, some reaching 700 degrees, 370 degrees, might offer the last refuge for life. Extremophiles, the toughest organisms on the planet, could cling to survival near these volcanic heat sources. If humans were to endure, we'd have to follow them, retreating underground into bunkers or vast subterranean habitats, warmed by geothermal energy and shielded from the cold vacuum above. To survive long-term, we'd need to create a new sun of our own. Artificial light and heat would be essential, not just to stay warm, but to grow food. Entire cities would have to function like biospheres, powered by nuclear fusion, fission reactors, or some future energy source. Farms would move indoors. Photosynthesis would be artificially simulated. Every calorie of energy, every lumen of light, would be precious. And even if we managed to power a new civilization, what about the human spirit? No more sunrises or sunsets, no stars to guide us, no moon to mark our tides. Just blackness, unchanging, infinite. Psychologically, this would be devastating. Our biology evolved with the sun. Our cultures are built around its rhythms. Without daylight, circadian rhythms collapse. Depression, insomnia, and isolation could become rampant. We'd be a species lost in the dark, physically and emotionally. The social consequences would be equally profound. Humanity might split into isolated underground colonies, each focused on survival. Communication between them would be difficult. Travel across the icy surface would be dangerous, if not impossible. Over generations, cultures might diverge radically, adapting to different geothermal pockets or artificial ecosystems. A unified global civilization might fracture into pockets of silence. Some might attempt to build space stations or orbital habitats to orbit Earth as it drifts. These could use captured energy or fusion reactors to remain operational, but maintaining such systems for centuries or millennia, without the logistical support of Earth's surface, would be a Herculean challenge. Worse still is the cosmic loneliness. Out here, far beyond the reach of our sun, we would no longer see the same stars. The familiar constellations, Orion, the Big Dipper, Cassiopeia, would blur and vanish as Earth moves farther away. The radio signals we once received from Mars rovers or from distant satellites would fall silent. We would be cut off. No communication, no contact, just the empty, unblinking dark. Could we survive? Maybe, with enough preparation, technology, and sheer stubbornness, a small fraction of humanity could cling to life beneath the frozen surface. But would we want to? That's another question. Living on a rogue Earth would mean sacrificing everything we've known. The sky, the seasons, the warmth of the sun, our connection to the solar system, to the stars. It would be a world without day or night, without direction, without a future written in sunlight. And even if we survived physically, would we remain human in any way that still matters? Let's say we don't launch Earth into the void. Instead of leaving the solar system entirely, we stay tethered to our galaxy. But with one big twist, we change where we are within it. We pick up our home planet and move it, closer to the galactic center, farther toward the rim, or maybe through one of the Milky Way's mysterious spiral arms. But just like moving houses in a new neighborhood, the change in scenery might come with unexpected dangers. In fact, it might be the worst decision we've ever made. Right now, Earth lives in a pretty cozy neighborhood. Our solar system sits about 27,000 light-years from the center of the Milky Way, in a quiet zone called the Orion Arm. It's like a peaceful suburb of the galaxy. Low radiation, few black holes, not many exploding stars. In cosmic terms, it's boring. And that's exactly why life on Earth has been able to flourish for billions of years. But what if we moved? Imagine drifting closer to the galactic center. At first, it sounds majestic. More stars in the night sky, glowing clusters, a brilliant light show, but what we'd gain in spectacle, we'd lose in safety. The galactic center is a chaotic war zone, packed with stars, riddled with black holes, and constantly bombarded with radiation from supernovae and neutron stars. It's a place where life as we know it probably couldn't survive. Radiation levels there are thousands of times higher than what we're used to. Even with Earth's magnetic field and atmosphere, we'd be vulnerable to DNA-damaging rays that could spark mass extinctions. And then there's the central supermassive black hole, Sagittarius A, a gravitational beast millions of times more massive than our sun. Getting too close could tear Earth apart through tidal forces or destabilize our orbit entirely. One wrong move, and we're cosmic toast. Now let's say we avoid the core and head through a nebula or dense star-forming region. Beautiful, yes, but also dangerous. These clouds are filled with gas, dust, and rocky debris. Traveling through one could strip away parts of our atmosphere, interfere with satellite communications, and expose us to impacts from asteroids and comets at much higher rates than we experience today. And don't forget the gravitational pull of passing stars. In our current orbit, we're relatively isolated. But move Earth into a more crowded region, and nearby stars could tug on our orbit, tilt our axial rotation, or even slingshot us out of the galaxy altogether. These gravitational tides could trigger earthquakes, volcanic eruptions, and tsunamis by shifting the planet's internal stresses. It wouldn't take much to throw Earth's climate and geology into chaos, but the dangers aren't just physical, there's something more subtle, more psychological. Oh, that comes with changing our galactic address, the loss of the night sky as we know it. If Earth moves deep into the Milky Way's arms, the constellations would change completely. The stars we've navigated by, dreamed under, and built stories around, Orion, the Pleiades, the Big Dipper, would vanish. New stars would appear, the sky would shift, humanity's entire cultural and mythological foundation would be altered. Ancient stories would fade, new ones might emerge, but there would be a deep sense of displacement, a loss of cosmic familiarity we've carried since the dawn of civilization. There's also the chance, however slim, of encountering alien life. Moving through different parts of the galaxy could bring Earth into proximity with habitable exoplanets, or civilizations far more advanced or hostile than ours. Would we be welcomed as explorers, or viewed as trespassers? Would they understand us or wipe us out before we even spoke? The search for extraterrestrial intelligence has long assumed we're quietly sitting in a safe spot. Moving Earth turns us into the noise, a massive, glowing beacon hurtling through space. In trying to escape danger, we might be flying straight into it. All of this raises a haunting question. Was our place in the galaxy a cosmic accident, or a stroke of unbelievable luck? Maybe Earth exists where it does because it had to, because life could only thrive in this rare sliver of calm, between the chaos of the core and the emptiness of the outer rim. By moving Earth, we may risk shattering the balance that made our very existence possible. So, could we survive the journey? Possibly. But again, would it still feel like home? Let's imagine we've done the impossible. We've moved Earth. Whether we've shifted it closer to the sun, pushed it into deep space, or steered it through another arm of the Milky Way, the result is the same. We are no longer in the same cosmic neighborhood. We've survived the engineering. We've dodged black holes, radiation, and ice ages. But now comes the deeper question, not one of physics, but of life. Could life actually adapt to a new cosmic home? And more importantly, should it? At first glance, it might seem hopeless. Earth's biosphere has evolved over billions of years under specific solar conditions: daylight cycles, gravitational pull, atmospheric balance. But even in the harshest corners of our current world, life finds a way. Deep beneath the ocean, around hydrothermal vents where no sunlight reaches, entire ecosystems thrive. In frozen Arctic lakes, acidic caves, radioactive ruins, microorganisms called extremophiles not only survive, but flourish. These tiny survivors offer a glimpse of hope. If they can adapt, maybe we can too. But the gap between surviving and living is vast. Humans, unlike microbes, are fragile. We rely on a narrow range of temperature, light, and air to function. So, in a relocated Earth, our first priority would be technological adaptation. Imagine vast underground cities powered by geothermal heat or nuclear fusion. Sunlight replaced with artificial spectrums that simulate circadian rhythms. Entire ecosystems rebuilt inside climate-controlled domes. We'd depend on indoor farming, hydroponic systems, and synthetic food production. Every calorie we eat would be engineered. Every breath would pass through filtration systems. Every moment of warmth would come from machines humming deep beneath our feet. But survival isn't just about technology, it's also about biology. A new orbit, or no orbit at all, might mean altered gravity, faster or slower planetary rotation, and different tidal forces. These changes could ripple through every layer of life on Earth. Ocean tides might vanish or intensify. Seasons could disappear. Human biorhythms would collapse, leading to mass sleep disorders, hormonal imbalances, and psychological strain. Over generations, we might even start to evolve. Taller, shorter, stronger bones, altered immune systems, or we might need to engineer our own evolution through genetic enhancement just to cope. And then there's the cultural impact, something science alone can't measure. So much of who we are as a species is rooted in the rhythms of Earth's original place in the cosmos. Our mythologies, languages, and calendars are shaped by the sun, the moon, and the stars. We sing about sunrises, celebrate solstices, and measure time in solar years. Remove that cosmic structure, and our traditions begin to unravel. But humans are storytellers. If we lost the constellations of Orion or the North Star, we'd likely invent new ones, drawing meaning from unfamiliar skies. New religions might emerge to explain our journey. New calendars could divide time by artificial seasons, energy cycles, light phases, or engineered harvests. We'd create new festivals, new songs, new dreams, because we have to. Culture, like life, adapts. Yet beneath it all, a haunting question remains. If we leave the sun, are we still Earthlings? Can we truly call ourselves children of Earth if the Earth we inhabit no longer spins under the same sky that shaped our evolution? If we change our planet's orbit, tilt, gravity, temperature, and light, does it remain the same world? Or are we merely dragging along a husk, geologically familiar but spiritually alien? And what about identity? Nationality, heritage, even geography, all these concepts begin to blur. Borders become meaningless in a survival bunker. Cultural divisions dissolve when every human is united against the cold silence of space. In that way, moving Earth could force us to evolve not just biologically, but morally. Maybe, just maybe, in the face of cosmic upheaval, we would finally learn what it means to be one species, Earth not as a location, but as an idea. But there's a bitter sweetness in that realization, because in moving Earth, we might survive, but we would never again be the same. So, what if we really moved Earth? It would be the most ambitious feat in human history, reshaping not just geography, but our identity, survival, and place in the universe. Would it be worth the risk? Could we handle the consequences? Or is it better to fix our problems here instead of flying off into the void? What do you think? Would you want to live on a traveling Earth? Is this the ultimate sci-fi fantasy or a dangerous daydream? Let us know in the comments. If you enjoyed this video, share it with someone who loves space and science fiction. Thanks for watching. And remember, sometimes the wildest what-ifs help us better understand the world we already have.